Hello everyone. In this video, we will see a prime number generator, right? So in the previous video, we saw that we saw a prime number checker, right? So if we give any number, that program checks if the number is prime or not, right? So in this program, we will give a number like 10, 15 or whatever it is, and this program will find all the prime numbers up to that number, right? So if we give 10, that the program will detect 2, 3, 5 and 7, right? So this is the functionality of this program, guys. So you see here how it works actually. So we have two files here, uh, as we've discussed before. This function is void type function. So what is void? Void means that this function won't return anything, guys. It will not return anything, right? So generate primes is the name of this function, and int, and this is a parameter. Okay, so we have to pass n as an argument, right? Something as an argument. Okay, so is prime is an array, guys. So what does actually array, what does actually array mean? Array is a collection of variable, you can say. Okay, so many variables will be here. So this is a boolean type. That means this array will only store true or false, guys. Okay, so how many numbers it can take, this array, how many values it can you know contain. So this n, whatever the n is, it will be n plus 1. So why we're doing this? Array start from 0, and array index starts from 0, and the number is, if you take number 10, so to reach 10 you need 11 indices, right? Because it will start from 0. Okay, so if I show you the array representation, or maybe array index representation, whatever you say. So if I just show you, I'm just going to this website for a few seconds. Okay, so if you see, guys, we have 12, 34, 68, 77 and 43, right? So we have 5 values here, but we have 4 uh, 4 value here, I mean 4 array index, right? So that means 0, 1, 2, 3 and 4. Okay, so array indexes will be always one number less, right? I hope you understand. So this is why we need to contain all the numbers in here. So this is why we're giving n plus 1, right? So now we are giving a for loop. So this for loop is for, these will contain all the numbers, and this will say everyone is true. That means everyone is a prime number, like 0 is a prime number, 1 is a prime number, 2 is a prime number. For the time being, we're just assuming that all the numbers are true, prime numbers, right? So uh, actually, if you want to visualize how things work, so we can do this as previous, so as previous video, but uh, let's just copy this one, and I'm just trying to make things visualize to you guys. Okay, so if you see, let's just delete everything from here. So for the first iteration, I is 0, right? I is 0. Let me see if I can just, okay, you start from I is 0, and I is less than n. So if you take 10, so 0 is less than 10, right? So 0 is less than or equal to 10, our condition is true. So now it will is prime I. So is prime I means 0 will be passed here. So this will true. That means I will be a prime number, right? 0 will be a prime number. Then this 0 will increase by 1. Okay, so 0 plus 1 means 1. So is 1 less than n or equals to n? N is 10, right? So this will be true again, and this 1 will pass here, is prime I, that means 1 will be true, that means this is also prime number. So this is how all the numbers will be prime. Okay, so this will iterate, guys, and all the numbers will be uh, stored as prime number, right? So we are assuming this, and now we have another for loop. Okay, so what does this for loop do? This for loop is just you know uh, this for loop is uh, just taking all the false values, right? This will just separate the false values, I mean non-prime numbers, right? So here, like I in the previous for loop, like this I, here we are taking a variable, another variable called p, right? And this p starts from 2. Okay, so this p into p, that means square of it, if the square of it is less than or equal to n, then this will increase by 1, right? So in this case, uh, you know uh, if you take this one for the first iteration, if for the I is equal to what, 2, right? Not I, p is equal to 2, and this is for the outer for loop, guys. We have another for loop inside. So outer for loop, first iteration, right? So we just need to just equal, like this. No, you just whatever it is, stay here. So then p starts from 2 and p into p, right? P into p is less than 10. So what is p into p? P into p is 2 into 2, 4, right? So p into p means 2 into 2 is equal to 4, and 4 is less than or equal to 10, right? So our loop will, this will go enter, right? And if is prime p, that means what is prime? Is prime is the previous for loop, previous the array, right? This array. So if you pass 2 here, 2 will be passed here according to our program, right? So if you pass 2 here, this will be true because all the numbers are prime, we know. Okay, so here this is also true. So as this condition is true, it will enter into this for loop. So inside for loop is inner for loop, you can say inner for loop. Okay, so let's consider inner for loop. Inner for loop starts from I into this int I is variable here, and it starts from p into p, that means 2 into 2. Okay, so I will be 2 into 2 equal to 4. I will be 2, sorry, I will be 2 into 2 is equal to 4, right? And this 4 is less than or equal to n. Okay, this 4 is less than or equal to 10, you can say. So this will be true, guys. But when it's true, it is prime I, that means is prime 4 will be false. That means 4 is non-prime number here. It's saying that 4 is false. That means 4 is a non-prime number. It's not a prime number. Okay, then it will increase I equal to I plus p. So what is I plus p actually? I equal to I plus p is equal to 2, right? We started p from 2. So in our outer for loop it's from 2, right? So here it will increase, like, let's say, okay, I'm showing here I equal to I, sorry, 4 plus 2, 6. So when now it will check again. Okay, so one thing, people make mistake, guys, when they increase the value 6, they start thinking from the beginning, right, from here. So I equal to now 6 into 6, 36. So it goes beyond, okay, beyond 10. Okay, so this is the mistake I did when I started. I used to think in this way, but the reality is you will have to think from this line. Okay, so these two things should be considered only, not this one. Okay, so in case of for loop, you just need to understand that uh, you just need to think from the condition and the increment operation. Okay, not the, you know, not the starting point again. Okay, so now 4 will be 6. So as 6 is less than 10 or equals 10, it will 6 will become also false, right? So it will again increase. Okay, it will again increase and it will be 8. So 8 will be false again, then it will again increase in the fourth iteration, then it will uh, 10 will be false as well. Okay, so now functioning of this is done for what? For 2, for p equal to 2. Okay, so p will be like start again, guys. Okay, so p will be 3 now. Okay, so after the fourth iteration of this inside for loop, okay, we did the 4 iteration. So then when it tries to terminate, it starts from here again because p hasn't finished yet, right? So p will be 3 now, and p into p, that means 3 into 3, 9. So 9 is less than 10, so it will go inside. Is 3 a prime number? Yeah, yes, because we considered everything as prime, so it will uh, be true and it will come here. So when I equals 3 into 3, that means it's 9, right? So 9 is less than 10, then is prime I here, 9 is false, right? 9 is not a prime number, 9 becomes false. Okay, so then it will increase, uh, 3 plus I is equal to what it is, I is equal to 9 here, so 9 plus 3, it will be 12. So 12 will be less than or equal to 10? No, because 12 is greater than 10, so it will terminate, guys. Okay, so when it terminates, then p will be uh, 4, right? So 4 into 4, 16, so it will not come again, it will not enter into the loop again. Okay, so now we are just separating the actual prime numbers, right? So after that we have another printf statement, prime numbers up to means percentage d means prime number up to 10 is okay, 10 r, prime numbers up to 10 r, this n is for 10, so this 10 will be here because for percent format specifier is here, right? So for p equals to 2, p will start from 2 again, and p less than n, p plus plus, so p will be less than n. So always remember these conditions, guys. These conditions are really crucial for your program, right? You see, this is the crucial part and these are the crucial part of your logic, guys. Okay, so the never always try to remember these things, guys, because you need to be careful enough and you need to keep your mind cool to remember them, right? So these, if you want to visualize these, p will start from 2 and p is less than or equal to n, p plus plus. Okay, it will go one by one, it will increase one by one and up to n. So it will start from is prime, it will start from 2. So is 2 a prime number? Is it will be true, so it will print true, print p, right? 3, it will also print 3. 4, it will be false because in our here we just proved 4 false, 5 true. So this is how all the prime numbers only be printed. Okay, guys, so like if you give 10, you see prime numbers up to 10 are 2, 3, 5, 7, right? So I hope you understand, I hope you got this point, and try to just pause the video and try to guys, try to imitate the code at least in the beginning, and maybe some other time, maybe when you become so fluent, you can implement this code in any other format or maybe any other way, right? So thank you for watching, guys. Keep doing and never lose hope. You need to do it, guys. And in the here we are just taking limit as a variable, and we are enter the limit, and scanf, this will take the input, and we're passing the generated primes. Instead of n, we are just passing this limit as an argument, right? So this limit, after passing this limit will start from here. It is the limit, guys, and then all the functions, all the things will be implemented. So thank you for watching, guys. I hope you understand everything. See you in the next video, guys. uh, Bye for today.